Welcome. In this video I'm going to show you how you can obtain different means using Python and some third-party libraries. I'm running Jupyter Lab with Python version 3.818. There are different kinds of means, although when most people talk about the mean they refer to the arithmetic mean, which is one of the three so-called Pythagoras means. The other two are the harmonic and the geometric. Um, They all have a geometry interpretation, but also, of course, a non-geometric interpretation. The arithmetic mean is what most people would call average. It's the sum of everything divided by the number of items, but it's actually also visually the balancing point of a distribution, the fulcrum as it's called, I think. The harmonic mean is often used with ratios, the geometric mean with compound interest, and because these means are quickly influenced by extreme values, there is something known as a trimmed mean, sometimes referred to as truncated or even Windsor mean, which simply removes some of the highest and lowest scores. A Winsorized mean does something similar, but it replaces then those values with the nearest non-removed value. Olympic mean I came across, which simply only removes one of the maximums and the minimums. And the decile mean is actually the average of the 9 deciles from 10% to 90%. There's also a mid-range, which is the average of the maximum and the minimum. And there's also mid-quartile range, but that I've discussed in the quartile ranges video. To show you how these can be calculated with Python, I need some example data, so I'm going to import pandas and then load the general social survey from 2012 adjusted for these example purposes. I don't need all the data, I just need one numeric example. So I'm going to be using age, but there was actually an 89 or older category in there, so I'm just going to replace those with 89. So that's why I set up a small coding and then used replace. I removed any missing values and made sure everything is numeric and store all of this under scale field. I have a separate video where I quickly show how you can just use my own library that has all these different means in it as a function, but there are other libraries where you can do some of those as well. Pandas itself simply has a function mean, and that will give you the arithmetic mean. Python itself has a statistics library, and it has the three Pythagoras means, so both the arithmetic um, and actually also the harmonic and the geometric. So once we have those in, you also can get the other two. NumPy has also a mean function, so I'm just going to call it npmean just so to differentiate it from the other one, and it gives the same result. SciPy has the three Pythagoras means, except for the arithmetic one, so actually only two of them, but in turn it does have a trimmed mean, so that truncated mean is available via SciPy stats. So the harmonic mean, the G mean, and the trimmed mean. There's also an option to actually winsorize your data. So if you use the mstats library from them, then you can just winsorize the data with the proportions from each side and then calculate the mean from those. So then you get somewhat of a winsorized mean. Alright, in a separate video I will actually also show you how you can do it without libraries, except the math library. But I hope this was helpful, and thank you for watching.